This lesson is on section 9.9 titled Scatter Plots. So a scatter plot is a graph that shows a relationship between two sets of data, and it often shows a pattern, trend, or relationship between the variables. So pretty much you can think of a scatter plot as just a graph of a bunch of data points. And when you graph the data points, you can come up with three different ideas from it. You can say it has a positive relationship, whereas the x increases, the y increases. So you can kind of see that, they're both going up in a positive direction. You can also have a negative relationship. So as the x goes up, or as the x increases, the y decreases. So it's that negative slope, that negative trend. All the data points are kind of going the opposite direction. Or you can have no obvious pattern or a no relationship, where the data points are just scattered everywhere. So that you can't really come up with whether it's a positive or a negative because there's really no pattern. So those are the three different types of relationships we're going to be looking at. So let's go to an example. So the first one says, explain whether the scatter plot of the data for the amount of memory in an MP3 player and the cost shows a positive, negative, or no relationship. Okay, so we're looking at this data here. I like to kind of circle it to kind of see the shape of my line. Automatically, I can kind of see that it's moving up. So it looks like as my memory or my gigabytes increase, so does the cost. And because that's showing that direct relationship, as one goes up, so does the other, we're going to say that it's a positive relationship. Again, as my memory goes up, so does my cost. Again, you can kind of, nice trick that I like to do is kind of like circle the data points to see the shape of that. Okay, the next example says explain, it looks like I had so it says explain whether the scatter plot of the data for the amount of, and it's not the amount of memory this time, it's the amount of ice cream sales for 2 weeks in May. So we're going to look at the amount of pints sold. Is there a relationship with the date that they're being sold at? Okay, so I'm going to draw kind of the shape of the graph here. As you can kind of see, it's kind of tough to draw that circle. And you can see that nothing's increasing, nothing's decreasing. So we can say right away that there's no relationship. That the amount of pints sold is not dependent on the date of when it was sold in May. Okay, so we first have discovered the relationships between the graphs. Now we're going to move into line of fit. And line of fit is a line that is very close to most of the data points. So what we're going to be doing is we're going to be drawing that line of fit within that scatter plot in order to figure out that slope and that equation of the line. So the example says make a scatter plot using the data, then draw a line that seems best to represent the data. So this example deals with cars, and this is the MPG ratings for a certain car company are given. So I'm giving the engine size and I'm getting the MPG ratings, miles per gallon ratings. For the sake of time, the graph is already done here. So if we look at, all these points, here, 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 those are all the points or the data points that was graphed, and that's what you would do. And then what you're going to do is you're going to kind of estimate where the line goes through the most amount of points, and then you're going to just draw that line through that data point. And that's all you have to do for that line of fit. You're given your data points, okay? This will be your x values, these are your y values. So all you're doing is you're graphing each one individually. You're graphing them on your coordinate plane, and then you're drawing your line of best fit. And then these 2 points are picked out for you because these are the data points that fall directly on the line, those 2 points. And those 2 points are going to be important because now we're going to take this scatter plot a step further, and we're actually going to find the equation of the line. So we need those 2 data points in order to figure out our slope. So let's think back a few lessons ago. How do we figure out slope? Okay, in order to figure out slope, we're going to do, remember that y2 minus y1 over x2 minus x1, or we can do the rise over run. Whatever example you want, I'm going to do the y2 minus y1 over x2 over x1 just because we have decimals here and it's going to get a little tricky with the rise over run. So I recommend that you use this example. Okay, so we have y2 minus y1. So I'm going to call this my y2, this my y1, this is my x2, x1. Okay, so my y2 is going to be 17 minus 19 all over 3.9 minus 3.4. So then I'm going to have 17 minus 19 is negative 2. 3 and 9/10 minus 3 and 4/10 is going to just be 5/10. So that's my slope, negative 2 over 5/10. Now I need to know my y-intercept, because remember the slope of a line or the equation of a line is y equals mx plus b. So what we can put here is we're going to say y equals my m, so we know it's negative 2 over 0.5 x plus, now my b is my x or my y-intercept. So where does this line intercept the y, my y value? So if I just keep extending it, looks like it intercepts it at 35. So I'm going to plug in 35 in for b. So my final answer for my equation of the line is y is negative 2 over 0.5. You guys are hearing my dog back there. X plus 35. And that brings me to the end of my lesson. I have to go grab my dog. Thanks for watching.